Okay, perfect. I think we are now live for another session of the weekly Vega Fairground or Testnet Jam. My name is Dagan. I'm a community manager at Vega, who you might have seen here and there. I'm usually quite active on the Discord, but I've been showing my face around Telegram this week. And this is the Vega Fairground Jam. It's an ongoing series, and it takes place every Thursday at 6 p.m. UTC +1 or British Summer Time. And each week we take a deep dive into a different aspect of the Vega protocol with a member of the Vega team or a special guest. Then we usually follow up with an open Zoom room so that any keen attendees may have a chat with the team and or follow up on some of the themes covered. This week, we are lucky enough to have smart contract extraordinaire Danny and also another smart contract extraordinaire, Emil, who will be showing us a few different demonstrations and answering a Q&A/AMA on the Vega token ERC-20 Vesting Contract. So whilst this is a testnet or Fairground Jam, these are the very real Vega tokens that we'll be talking about today. So disclaimer. As always, some quick housekeeping before we begin. Whilst Danny is presenting and Emil as well, you're free to ask questions in the Twitch chat and they will be able to answer those at the end of the call. If there are particularly relevant questions, we'll take them throughout. And then about 5 minutes before we end the session, I'll post the Zoom link in the Twitch chat and then you guys can come and join us for the post-Twitch Zoom meeting. And we really encourage you guys to come along. You can continue the conversations that we've started here in this live stream. So without further ado, let's begin. First question is over to you, Danny. Can you briefly explain why there is an ERC-20 vesting contract? What is it for?
Well, first off, thanks for having us. Thanks, Dagan. Thanks, Emil, for being here. I really appreciate you showing up. I'm going to be giving a lot of props to this guy, so hopefully we embarrass him and he gets all like flushed and stuff. Like that's really what we want because this man pulled through. It blows me away. Okay, but the ERC-20 vesting contract is specifically to avoid this common problem. And I don't want to use the term ICOs. I don't know what the current term of the day is, but basically a lot of these projects have a founding team and founding members and early investors and all this stuff, and they build up their product and build up their product. They do the token sale, and then they dump on the community, and everything's toast. It's the standard rug pull, the standard exit scam. We have created the vesting contract to stop that from happening. We've created multiple vesting tranches that vest at different rates and release tokens slowly at different rates so that there's no one easy, we're gonna all dump at this moment time. It's unfair to the early investors. It's unfair to the late investors. It's, this is, if anyone has paid attention to like Wendy and things like that, we really care about fairness here, and we really care about fairness of the community and how they interact with our protocol. And vesting and having different ramps is our way to make everything a bit more fair. That's the best I got for that one. But long story short, you get tokens slowly unlocked. And yeah.
Very eloquently put. Nice answer, Danny. Thank you.
Sorry, it's the best I got.
That was great. That was great. So second question is, was deploying the tokens a simple process? Did anything interesting come up? And can you maybe give us a demonstration of the process of doing so?
It was not an easy process. So prior to, 2 weeks ago, I think it was when we did this, I had planned to just bulk run the issue process over and over and over again. And on that Monday, our good friend Emil here decided to join us, and he was dumb enough to open his mouth and say, hey, why don't I write this script that uses some really obscure assembly language and some really obscure commands to bulk issue? We'll save a bunch of gas. And me being, like all in awe of his awesomeness, I said, yeah, let's do that. And yeah, I'll let Emil take it from there. Go for it, dude.
Thanks. Yeah, I guess, yeah, I was stupid enough to open my mouth, but I looked at the what Danny talked about. I think we had something like 3,400 transactions that were going out to issue the tokens into all the people who bought during the coin sale into their wallets, at least the people who had chosen self-custody. And instead of trying to fire off 3,500 transactions on Ethereum and having to wait for them and sitting in the mempool, I had previously been doing like these kind of bulk actions on Ethereum, and I knew we could do it easier for ourselves by doing it in batches, so it was atomic, and we could save a lot on gas if we actually coded this thing up in Ethereum bytecode instead of doing it in Solidity, because as nice a language as Solidity is, in some ways the compiler is still a bit immature, or it tries to it tries to kind of have a uniform interface that anyone can talk to. But
sorry, Vitalik.
That is nice when you're trying to make contracts that interact with each other. But once you want to do these huge batches, you can save a lot of gas by doing it by hand. So that's what we did. Do it by hand. So I'm just going to show you quickly what that looks like, because at least Danny thought it was really cool, and I know it's not a specifically a Vega thing. It is a low level Ethereum thing. So maybe you'll find it interesting. So I'm just going to share my screen here and then see if we can pull up the. I made a screenshot of the bytecode that we actually used to issue the token. So when you write contracts in Solidity, you have the option for emitting the contract code as this intermediate representation called YUL, Y-U-L. But YUL is actually also a fairly nice language to write in by hand. So anything you write in YUL is just taking the EVM bytecode instructions and then attaching the mnemonics on there. And then it has a couple of small, nice, nice helping instructions for you to actually write code that you can understand. The other nice thing about YOL is that you actually get down to the place, you get down to the level of what is the Ethereum virtual machine actually doing. You get to see everything, and in my mind, yes, it's a bit harder to read because you have to learn the language and you have to learn what the EVM actually does, but it also allows you to make less mistakes because you're not sitting in a high level language that has to be you have to try and translate down to something lower level. You're actually looking at what is going to go on the chain. So this is what YOL looks like. It has this concept of objects, and an object can have code and it can have other objects. So that's what's going on here. So here we have this batch issuance contract, and the first block of code here is what would normally be a constructor in Solidity. So you can see the first thing it does is that it says, well, we're going to copy some data from another place in this file, and in this case, we're going to copy this object called runtimes. That's the code that's actually going to be deployed on the Ethereum blockchain once this contract construction has succeeded. So yeah, the first line is just copying that code into memory. That's how it works. Then there's a couple of YOL specific things. These are not EVM instructions, but this set immutable, that's kind of a function you can use to manipulate the code before it's deployed, because code is just data. So in this case, we actually have two different immutables we want to keep track of. We have a controller, which is just a security mechanism that says, okay, only one specific address is allowed to interact with this batch issuance contract. And then later on, you can see down with, if you go to this block at the top of my screen now, that's just putting in the vesting address, because we don't need to load this into memory all the time. We can just hard code it into the contract as we deploy it. And that's actually what a constructor is when you write Solidity contracts. It's a a function or like a set of instructions that set up what is the initial memory space and what is the initial code that's going to be deployed on the Ethereum blockchain. And then all the constructor does is at the end, it says, I'm going to return a range of bytes, and these are the ones that you're going to commit to the chain that then can be executed later on. And then we get to the runtime code. So that's this runtime code is the code that actually goes on to the Ethereum blockchain. And yeah, it's maybe a little bit foreign, but you can see the first line here. We just make sure that it's only the original address or a wallet that created this contract, that's also allowed to call it. And there's a nifty little trick in here that I don't think Solidity does, but you can do when you do this low-level stuff. Instead of reverting here at the end of the if expression, we use this special EVM instruction called invalid, simply because it's cheaper. That's only I think it's only 3 gas to use invalid, while if we were trying to revert, we would actually have to say revert and then a byte range of what the error was. So that comes out to, you can see I actually wrote it up here in the top. That comes out to first a push instruction, and then you have to put in the byte that you're pushing onto the stack. And you have to duplicate that because revert takes 2 arguments, which is 2 byte ranges. Anyway,
I'd like to interject 1 second. I'd like to interject here.
Yeah.
To anyone watching who is wondering why Ethereum is so like obscure and hard to code for and stuff, this is why. We're genuinely thinking about every piece of gas we use. We really care about these things, and Emil here just takes it to a whole nother level. I just wanted to throw that out there.
Thanks, Danny. I think the next thing that is actually just a comment here is where the clever part comes in, because when you interact with Solidity contracts, you have to format the inputs in a very standardized way, but often that can be quite inefficient if you're trying to do big batches of stuff. In our case, what we needed to do to issue tokens to our users was obviously, we need to use what address is the token's going to go into, or like who's going to be the recipient of these tokens. Then we have this thing we call a tranche, and that's like the kind of the vesting cliffs. That's just 1 byte because we only have less than 256 of them, so we only need to spend 1 byte here. This is something where at this point Solidity would have spent 32 bytes on the address, even though it's only 20 bytes that are actually matter. The tranche would have been another 32 bytes, even though it's only 1 byte that actually matters. And then in our case, 10 bytes was sufficient for the amounts here. Still keeping in mind that Vega tokens have higher precision than you can keep in 10 bytes. But looking at the token sale, no one bought more than 10 bytes for a single address. So that way we could pack everything way more efficiently. So in the end, this for a single issuance, this comes out to 31 bytes, where normally calling a Solidity contract, this would have been 96 bytes plus something called the function selector, which is another 4 bytes. So 100 bytes for every single call. But we could pack this in, which meant we could do way more issuances per transaction we submitted to the Ethereum blockchain. And that's some of the stuff that goes on here. You can see there's like this very long string here of bytes. At the front of it, you have 4 bytes that actually matter. That's the method selector. You can look up how this is calculated in the Solidity docs. But it just has to be flush to the left. So that's why you have a lot of zeros padded up the end. Another thing here is we keep track of the memory that's used very, very at a very fine level of granularity, because that way we can also save a lot on gas. And then we also never copy the data we're gonna use in Solidity. Often you would copy all the input data into memory right away, but Solidity actually has 3 types of accessible storage, if you say so. There's the call data, which is the data you actually send to the transaction. Then you have memory, which you pay for. So that's runtime memory is going to go away once the transaction is done. And then you have storage, which is your long-term persistence across transactions. Then it's just a loop over all the issuances we want to do. And then there's a little bit of bit hacking here to get it all to fit. And then, call out to the vesting contract. And this loop just goes on until there's no more data. And then at the end, we have another nice little EVM trick that instead of normally when you finish up a function, you want to return, and there is a return instruction in EVM and takes 2 arguments, just like revert. What is the byte range for the result we want to get back to whoever called us? But stop is a single instruction, so it's cheaper. I mean, in this case, it didn't really matter too much because we're only going to stop once. It's just another nice little trick you can do in low-level EVM. So that was a little bit of low-level EVM bytecode, and once you get the hang of it, it's actually not very complicated. Something like an ERC-20 contract is less than 100 lines of this EVM bytecode, and if you code it up by hand, sure, it's harder to read for someone who's not trained in EVM byte language, and it's also perhaps a bit harder to maintain because you always have to think at this low level. But I mean, there's only so many things that you do with a, for example, ERC-20 contract, that when you do it at this level, you can really optimize for the gas cost, and you can make things much cheaper for your users, and you can make it way more efficient for the chain. Yeah, so that was just, you know, to give a little bit of a taste of how did we actually issue the contract, all the tokens. Doing it this way, we could fit 175 issuances into each transaction. So instead of it being, you know, 3,500 separate transactions, I think we only had 12 transactions in total. And in, you know, those 12 transactions took up a whole block on the Ethereum chain, which was also pretty cool to see that, you know, every once in a while there was a block with just one transaction in there. And that was our, you know, our issuance that was just taking up all the gas available for that block. So yeah, that's what it is. I mean, it's not actually not a lot of code. There's a lot of comments in here just to document what is it we did and make sure that someone else can come along and verify and audit that it's doing the right thing. So yeah, that's it for me, I think.
Dude, thank you so much for showing that off. So I'm going to parrot something that Klaus said, I don't know, like a year ago or something. I gave a talk and it had nothing to do with Vega. It was all about bubbles and whatever. And he said, you know, even though he didn't mention Vega, this is proof of person, like proof of competency. Like, to everyone watching, dude, like I barely understand what the hell Emil just said. It's absolutely mind-blowing, but it worked, and it worked flawlessly. We saved so much ether on deploying all of these different issuances. Like it blows me away. You did excellent. Thank you.
It was cool. I don't know. I actually see there's a question over on Twitch about how much gas we saved. Do we take questions now?
Yeah.
Or maybe we just talk about it quickly.
Yeah, go for it.
So back of the envelope calculation for doing it like this is Ethereum baseline doing any transaction is always 21,000 gas. Doing a call inside a transaction to another contract, if you're not transferring either and you're not sending too much input to that other contract, it's only 9,000 gas. So the difference is then 12,000 gas. So every single, you know, issuance we could batch into, you know, one big transaction was saving us 12,500 gas, which is, you know, pretty considerable. Obviously, it's not exactly 12,500 because the code I just showed, there's some instructions going on there that do cost some gas, but we're talking maybe 100 gas for each of those calls out, and then the 9,000 to actually call the other contract. So, but it wasn't so much about gas savings for us. It was more about the atomicity, because if the transaction here actually goes through, we know it's done and it all happens at once, instead of having, you know, 3,500 transactions that each have to queue up after each other and, you know, maybe get dropped from the mempool and you have to rebroadcast and all this stuff. Here we just knew, okay, now they're in the mempool and we know it's going to go through. And once each of these go through, it's atomic.
We did have one caveat on there where we ran out of gas on that one. Would you like to tell me about that one? Yeah, so we had one. We had one of them ran out of gas. I'm not exactly sure what you're hinting at, but yeah, if you do run out of gas here, so it's running in this side loop. We ignore reverts. That was one of the instructions that maybe didn't point out. So that's also where what we were doing here is maybe a bit more dangerous, but we knew what contract we were calling into. We knew exactly what it was going to do on any kind of input. So we could already see from the get-go that nothing was going to revert. Then we did have one transaction that ran out of gas at the very end. But again, you can just go in and look at the trace that's coming from, you know, a Geth or whatever, and you can see, okay, which of these ran out of gas and didn't complete, and, you know, we put it into the next batch. Yeah, actually, I manually issued that last one. I'm amazed. Yeah. Like your gas estimation was so good. We were just over by like that much on that one very last transaction. So yeah, the whole thing was just brilliant. Good work, dude. I really can't overstate that. Like Emil showed up on Monday, and yeah, by Thursday we had done this, and he knocked it out of the park. He's probably the best acquisition we've made at this point. Like I'm not gonna brag too much, but like Emil is the shit. Like, yes. Anyway, that's it. Dagan, back to you, I guess.
Thank you, and great job, Emil. Fantastic job. Like, we honestly love the work you did, and thanks for presenting it in such a nice, coherent way. You're free to come to more testnet Fairground Jams in the future if you want to talk a bit more. But yeah, I guess I'll get a lot going with the Q&A. We had some more questions in the Twitch chat, and we'll get to those further down the list. But the first question I have for you is, Danny or Emil, when is the earliest token unlock? And when is the final token unlock?
All right, cool. So the first token unlock starts on 3 September. There is a group, it's the option 3, which was the most expensive option, but it unlocks fully in one go on 3 September. All of the others are ramped up, and there's some timing and stuff. The final unlock is for the early team members. It's their round B. We have a blog post on that Dagan will share to everybody. But that fully vests on December of 2023. I think it's December. Actually, I don't know the date. So it's December 2023. That's when the final one will be unlocked. And at that point, all of the Vega tokens will be vested and ready to withdraw.
Nice. I just shared the blog post in the Twitch chat, so if any of you are interested, do have a read.
Thank you.
Next question. What about for those that took part in the $5 community member allocation, the people that were early access with Vega?
Right. So if I was reading the spreadsheet correctly, if everything was set up correctly, the tranche starts vesting on 5 June of 2022, and it ends in 5 June 2023. It is linear vesting, so at any given time, you will get exactly what the percentage through the vesting period, it is. That's how much you'll be able to withdraw.
Nice. I'm going to get to a question a little later on just how exactly we withdraw them and stake them. But just a question related to the wallet allocations we were doing earlier this week. If you did choose to receive your token allocation in a Vega wallet, well, sorry, not in a Vega wallet, in an ERC-20 wallet, you had to check your token amount via an EtherScan link. Will there ever be an easier way of checking how much Vega token you have, when it's available, and how you can access it?
Yeah, so as of right now, you can go to EtherScan and run the user total all tranches function, which will you provide your address, and it'll spit out how much you have vesting at the moment, how much you have locked, basically everything you haven't withdrawn. There will be a user interface that is a link off of console, off of Vega console, that will be available at some point. I don't know the exact timing on that, but yeah, it'll just be a link that you can follow, put in your address, or connect to Web3, and it will give you your total vesting. I do want to point out that EtherScan is available right now, and EtherScan will always be available because they are an objective third party that, they're not us. We don't own them. We have no involvement with them. So any data you see on their site, you can more or less trust, because, they have no vested interest in propping up our claims. So if their data matches our data, it's probably accurate.
Yeah, code is law. But if you want an easier interface, there'll be an easier one in the coming months, coming weeks.
Yeah, we don't know on the timing at the moment, but yeah.
We also might have another thing that we're working on, which is a kind of like a ERC-20 proxy contract that you can add to your wallet, and it will show you what is your balance of Vega that is locked, but it won't show you, when does it unlock, and how much Vega token do you have available right now. It's more of a utility that you can add in, so you can actually keep track of how much Vega do you have, and perhaps just keep track of the exchange rates or whatever. It's a maybe still. We're still figuring out if the user experience is actually nice, but it might be coming out in one of the next weeks.
Yeah, that'll make things a little bit easier, because the problem, everyone uses MetaMask or some sort of Web3 wallet, and they all have their balances in there, and you can add custom tokens and everything's cool there. But MetaMask doesn't natively support things like vesting or anything like that. So we are building, I think Emil is actually heading that one up, a proxy that will show your balance in the vesting as an ERC-20 token. Slightly complicated, slightly, outside the norm, but I think it's a very good idea. And I think if pulled off correctly, and if Etherscan plays nice, which we still don't know if it will, it should, but we don't know, it will be a good addition for the community.
Yeah, nice. We're trying our best to give as many ways as possible that you guys can view the tokens that you have, and so yeah, it's as user friendly as it can be. But Etherscan will always be there for you, and it will never run away. So if you check your email from if you delegated your tokens to an ERC-20 address, you will always be able to check it over there. So next question is, once the tokens do unlock, how exactly would I claim any Vega I have? Is it automatically deposited into my MetaMask or hardware wallet, or do I have to claim them myself?
You do have to claim them yourself. There is a function on the vesting smart contract called withdraw from tranche. You have to specify which tranche you want to withdraw your tokens from. Now you can do it through Etherscan. You can put in all the details. It's a bit complicated, but it's doable. Otherwise, we will be providing a user interface for that uses Web3 and connects through there. At the end of the day, all a user needs to do is run the function on the smart contract. However they do, there's tons of different ways to do it. I mean, MetaMask, we talk a lot about MetaMask, but it's only one of many, many ways. You can do this through My Ether wallet. You can do this through Ledger has a DApp interaction thing that allows you to import ABIs. There's a lot of different ways to do it, but at the end of the day, just run the withdraw from tranche at any time, and you will get whatever is vested for that tranche for your wallet address.
Thank you. Yeah, that was a good answer. Yeah, we're trying to make it as easy as possible when the time does come that they do eventually unlock. That's basically
right. And you're totally right. If anybody does run into a problem where they can't use the tools that we have available, or they can't follow the instructions we have available, please reach out to us. We'll come up with a different way to provide this access to our users, because the user experience at the end of the day is the most important thing.
Amazing. Yeah, thank you. So that's about the ERC-20 wallets, but what if my tokens are held in CoinList? Are those ones automatically added to my wallet? How do I get the ones if they're on CoinList?
I have no idea. So we will be issuing the total amount to CoinList, and everything past them is handled by them. I have not gotten any update from them specifically on how they're going to handle this, so I don't know. I'd love to just BS my way through it and be like, oh yeah, they're going to do this. I don't know. So I don't know if they plan to withdraw and automatically issue at given intervals or only at the end. I'm not sure. That's something we're going to have to take up with CoinList at some point. Sorry.
Okay, yeah. I mean, CoinList has done it before, and I'm sure they'll do it again.
Right, so, and that's the thing. They have an infrastructure around this. Honestly, if anyone has experienced a previous CoinList round and would like to share the experience or give some insight into how it goes, that'd be great. Otherwise, I just don't know, and I can't speculate.
Okay, perfect. Yeah. When the time is there, you will be able to get them. That's all we know. And we're sure that will happen.
Yeah, I mean, it's
Um,
pointless. It's like you said, they've done this before. Like, I don't expect they're gonna pull some extra scam for us. There's bigger whales out there that, you know what I mean? Like,
yeah, no way, no way. Okay, once I do get them, or even when they're unlocked, how do I go about staking my Vega tokens?
cool. Okay, so there's two methods. One of which is actually during the vesting process. You can run the stake tokens function on the vesting smart contract, which will stake your tokens and you will get credited with them in Vega. Otherwise, once you have withdrawn them from vesting, you can run the stake. You can run the stake tokens contract on the staking bridge. It ends up being the same thing in the long run. It's just that some people will have withdrawn their tokens and some people will have not. So yeah, those are the two ways. For the meantime, for everybody until things start unlocking, I'd suggest using the vesting token stake token function. There will be a UI for this. There will be interaction for this, but as of now, the easiest way would be to run that function on the smart contract.
And to confirm, you can only stake these tokens once the mainnet goes live. And that may be around the September the 3rd. It could be after, it could be before, but it's once the mainnet goes live. So
Yeah,
there's no
correct.
exact date right now, but we're expecting it around Q3. So
correct. And I don't know the exact date. There is no internal information on the very specific date or anything. So yeah, that is the best info at the moment.
yeah, you'll receive your tokens on September the 3rd if you're option free. But yeah, for when you can stake them, that's when mainnet goes live. And we're working as fast as possible to deliver that to you guys.
To be clear, you can withdraw them if you're in option 3 on September 3rd. You already have them issued to you. Unless something goes horribly wrong and we have to redo this whole process, which, yeah, see that look on Emil's face? Yeah, I feel that exact same thing.
Okay. Fingers crossed, nothing's going to go wrong. We're a competent team.
Oh man, immutable code, man. It's immutable. What are you going to
do? You're right.
We can do it. Okay. I think that's more or less most of the questions around the vesting schedule. Where could I learn more about the ERC-20 Vega token? To be honest, we've answered that already. I shared the link for the blog. And you guys can check it out where we've got full details for the vesting schedule. Someone in the Twitch chat says, Danny, you're hilarious.
I try, dude. I really try.
Okay, well, yeah, that's more or less it. Do you have any other comments or things I've missed out or anything that you think the community should know?
I think the community needs to praise Emil's name and really, really get behind him and like if there was a little cult that followed him around giving him praise, I would be very happy about that. Emil, dude, thank you. You saved our ass. Like, I mean, I could have done this without you, but it would have been a lot more expensive and a lot more time. And I really appreciate it, genuinely. And I would love the community to understand how good of a dev we got in Emil. Like, I'm good. This guy's a whole nother level.
And you have to remember, I'm Danish. I don't take compliments. So yeah,
it's part of why I did it. You know, just mess with you.
Yeah. Think so.
Okay. Yeah. Thank you, Emil. Thank you so much. Hopefully, yeah, you keep it up because yeah, you're a great addition to the team. Thank you for joining this testnet Fairground Jam. I think that's it for this week then. Thank you both for turning up as our special guests.
Come on, guys, really? No more questions?
No one's got any more questions for us. But I did post the Zoom room. So if they want to join the Zoom room afterwards, we are going to go ahead over there. If you want to chat a bit more to Danny or to Emil, we'll be there for about 10 or 15 minutes, maybe longer if everyone joins. This, as always, will be hosted on YouTube shortly after. So probably tomorrow, I'll have this uploaded. And then you can watch it back. You can check for any details you might have missed or you want clarity on. I hope we could answer most questions you might have had around the token contract. And yeah, let us know in the Discord server or Telegram or wherever if you have ideas for future Fairground Jams and other topics you want us to cover, because we're always happy to get members of the team talking and speaking to you guys about whatever features or things that we're doing that you're interested in?
Yeah, seriously. We get messages internally all the time from people in the community messaging saying, "Hey, what about this obscure thing that I never would have thought of?" Like we love that. I really want that, because I can only think of so much. We can only think of so much. Like, we want that from the community. So please reach out. Thank you.
You heard it here first, guys. Emil, any last words?
I want to say thank you for the opportunity to be on here. I hope to see you again soon. Be back.
Thank you. All right, that's the end of the stream. See you guys soon. Until next week.
See you
Bye-bye.
soon.
Thanks,
Bye-bye.
Megan. Thanks, Emil. Thanks,
Join the
guys.
Zoom room.
Thank you.
Yep. Bye.
Bye-bye.